Alright, lesson one, your foundational terms of geometry. You should have out your vocab organizer. We're going to fill that out as we go through this lesson. You will need the definition, sketch, and the name of the sketch. Throughout this video, feel free to pause and rewind as you need to. We're going to go through some stuff fast. If you have questions, make sure to write them down and ask them in class, before school, after school, whatever works best. So our learning goals for this first lesson. At the end of the lesson, you should be able to describe, define, sketch, and symbolically name the following geometric figures: a point, line, plane, segment, ray, angle, collinear points, coplanar points, and opposite rays. So to begin with, we have a point. It is indicated by a capital letter and a dot. It has no size to it. So here we have point A, and I can make a point B as well. Lines in the type of geometry we do are always straight, and it extends in opposite directions with no end, so it goes on forever. It also has infinitely many points. So like this line down below only has 2 points. We could add another one. Infinitely many. To name lines, we have several ways. I'll erase this for now. We can use 2 points on the line. So in this line we have AB, and then the symbol on top is a line. So I read that as line AB. When we name lines, it doesn't matter which way we name them. I could call this line AB, or I could also call it line BA. Either one is fine, just don't forget that symbol up top. You also notice in this line, there's a tiny little italic letter. We can also name lines with that lowercase italic letter. So this could also be called line L. So different ways to name the line. Let's look over on the right. We have a line with a couple points. The points that we have are points E, F, and G. So we have 3 different points. And then I can name my line lots of different ways. So I can say line EF with my symbol. I could call it FG, or I could call it line EG. Don't forget your symbol up top. Also, again, notice it has a smaller lowercase letter up top. I could also call this line P. So those are points and lines. Next, we have a plane. It's kind of a flat surface if you think about it, like a piece of paper, book, desk, anything like that. It goes on forever, just like lines in all directions. Doesn't have any depth to it or anything. And a plane contains infinitely many lines. So when we talk about naming planes, we need to name planes by at least 3 points in the plane, and they can't lie on the same line. So you notice in this plane, I have points A, B, and C. I know they're not all on the same line, so I can call this plane ABC. You'll notice that this capital P doesn't have a dot next to it, so I know it's not a point. We can also refer to our plane by a capital letter. So this could also be called plane P. Okay, so look at the top right. We have a plane. I can call it any order with these 3 points. Plane, I'm just going to call it X, Y, Z. You could call it plane YXZ, ZYX, anything like that. Also, just like the last one. This W doesn't have a dot next to it, so I know that's the name of the plane, so I can also call this plane W. So those point, line, and plane are kind of our basic terms, and then we just build on from there. So the next term we have is a segment, a line segment. It's part of a line that contains two endpoints and all the points between them. You'll notice on this example that there's nothing after the A or after the B. It doesn't extend beyond that. Line segments get cut off right at those endpoints. So to name line segments, we do the same thing kind of like we do lines. We take our two endpoints, and then our symbol is just a line segment. No arrows this time, just line segment AB. Also, like lines, I can switch them up. I could also call this segment BA. So we always want to name it with our two endpoints. So looking at the right, I have a line EF or line FG, anything like that. And so there are a couple different line segments in here. You notice I have 3 points, and each point can be connected to another one to make a line segment. So I could have EF, I could have FG, and honestly, I can also have a big one, EG. Those are all line segments, so let's write those down. I have segment EF, segment FG, and segment EG. And like I said, those could all be flipped around, FE, GF, GE, anything like that. Next we have array. Array is part of a line that consists of only one endpoint, and then the other side of it goes on infinitely. So here our endpoint, you'll notice, gets cut off at A, and then as we go towards B, that has an arrow, so it goes on for infinity. Now arrays are the ones where we get picky. We have to start our array name with the endpoint. So in this case, where it gets cut off, A, that's the letter we start with, and then the next letter is what it goes towards. So in this case, B. And then the symbol above it is array, kind of tells you, stops at A, goes towards B. If we had another point on this line like C, I could also call this line AC, just so that we get a starting point and then a direction of where that array is headed. So looking to the right, I have array. My endpoint is M, and my array goes toward point L, so I would call this array ML with my symbol. Next we have opposite rays. Opposite rays are two rays that have the same endpoint. They also form a line. So in this bottom example, I have 3 points, A, C, B, and I want to try to find two rays so they have the same endpoint. So they have to start at the same place. I kind of like to think of it as the middle. I always look to the middle. So here my middle is C. If I made that an endpoint, I have one ray going towards A, and I have one ray going towards B. You'll notice that makes a line, and those are indeed two opposite rays. So I said ray CA, starting at C out to A, and the other one CB, ray CB, starting at C and going out to B. So those are opposite rays. They form a line, and they have that shared endpoint or middle point, however you want to think about that. So looking at the right, have 3 points, E, F, G, and I want to find opposite rays. So I look for their shared endpoint. Well, they share F, and then it goes towards E, goes towards G. So I can say ray